Hello, so in this video we're going to be talking about quadratic functions and in particular the shapes of quadratic functions and vocab associated with them. So a quadratic function will always have a shape that looks like this. This shape is called a parabola. And you will see parabolas that look happy and you can see parabolas that look sad. The way the parabolas are shaped, whether they're happy or sad, have a specific word that goes with them, and this is called concavity. So this guy is concave up, and he's happy, okay? So a happy parabola, concave up. If you have a sad, grumpy parabola, we would call him concave down. All right, so when you're talking about the shape, whether it's happy or sad, we're talking about concave up versus concave down. The next thing we can talk about is the location of my turning point. And the turning point is the same thing as a vertex. These words are synonymous. So when I look at this parabola, the vertex is here. The vertex is always where your graph is turning. And we like to talk about that if you're given a graph, you want to talk about it as a point. So I went over -3 and down 16. So the turning point here is -3, -16. That's an important point, okay? So let's see, what other points are important on this graph of a quadratic function? I see these two guys. These are my x-intercepts. So we will talk about those as a point. So my x-intercept was over -7 up 0. And I have another one, which is over 1 up 0. Sometimes parabolas will have no x-intercepts. So if I drew a parabola down here, notice how he will never cross the x-axis. So that one has no x-intercepts. You can also draw a parabola that just has one. If I put the vertex right on the x-axis, you'll just have one x-intercept. Synonyms for x-intercepts are, you can see the word roots, and you can also see the word solutions. So if you see these words, x-intercept, root, solutions, they are all asking you about where your graph crosses the x-axis. And we'll talk about these at a later point. Okay, there is one more point that is important to note, and that is right here, our y-intercept. So in this graph, my graph crosses at -7, and we've been working with y-intercepts pretty extensively. So the coordinate in this case is 0, -7. Remember, with your y-intercepts, x is always equal to 0, so you just need that y. Okay, so those are 3 points that are important on our graphs. The next thing we'll just talk about is symmetry. When you draw a parabola, if I drew half and I stopped at the turning point, you should be able to draw the other half because it's symmetrical, okay? And the line upon which my graph is symmetrical is called the axis of symmetry. Now, I made that x really big on purpose because it's an equation. And the equation is always x equals some number. So at what x value is this graph symmetrical about? So if I look at my vertex, I know I'm going to draw this line straight through my vertex. So the x value that my graph is symmetrical about is x equals -3. And so that is my axis of symmetry. So you'll see below here, there is a picture of a quadratic with the ability for you to fill in some features. So why don't you do that? Pause the video, and when you're done, check your work with my answers below. Okay, so here are my answers to these guys. If you have any questions on why these answers are what they are, please let me know.